Hello everyone! Today I'll present an alternative approach for system modeling, that is C4. If you hate UML diagrams or use Agile for software development, you still need graphical tools to make your system more understandable to everyone. So, you still need to draw informative diagrams. There are many ways to do that. Even though the different companies are talking about similar tools, they still can draw pointers, connection lines, and symbols differently. Also, new employees may have their own methods and notations. To unify all those sketches and symbols, the C4 modeling approach has been proposed. In this case, you can still draw your diagrams, but in a more systematic way to make sure that a new employee could understand your system. The main notations should be used in the same way, for example, connection lines, pointers, and so on. In C4 modeling, only 3 main diagrams must be created. Also, 3 additional ones could be added to your system description. C4 is based on software map as an analogy of Google Maps. It is oriented to whiteboard-friendly modeling and should be easy to use. C4 model map has 4 zoom levels and is based on an abstraction-first approach. The small set of abstraction and diagram types make the C4 model easy to use and understand. By the way, C4 also has sufficient support for different software tools. The most popular one is Structurizer. There are many extensions for popular modeling tools, for example, Enterprise Architect, Visio, and other tools. As I mentioned before, C4 is an analogy of Google Maps and is called Software Maps. It is mainly based on navigation. Let's say we are driving a car and we want to look for the way or direction to choose. In this case, we can zoom the map or expand it to see more information, for example, in which crossroad we should turn. In this slide, you can see the analogy for software maps. Here we have 4 levels of software map. For the basic concept, for example, in which country your home is, the highest zoom level is preferred. Now you can see where your home is compared with different countries. So the first level is called system context. If we go deeper into our system, we have container diagrams. In our example, the container shows roughly where your home is. Further zooming shows component diagrams, and finally, for the full description, we reach the lowest zooming level and see code diagrams. These diagrams show how each individual component of our system is implemented. In this slide, you can see a similar path of zooming levels. The whole system is marked in green color. As you can see, in the first level, some context about the system is also shown. The system consists of separate applications, in this case 4 applications and a database. Each application has interfaces that are described using component diagrams. The lowest level is optional and shows the implementation of your code. The C4 model consists of several abstractions. It considers the static structures of a software system in terms of containers, components, and code. And don't forget that people use the software system that we built. A person represents one of the human users of your software system, for example, actors, roles, and so on. Also, a software system is the highest level of abstraction and describes something that delivers value to its users, whenever they are humans or not. In C4 model, a container represents an application or a data store. To make the overall software system work, containers need to be running. For example, server-side web app, client-side web app, mobile app, microservice, database, file system, shell script, and so on. A component is a grouping of related functionality encapsulated behind a well-defined interface. If you are using a language like Java or C#, the simplest way to think of a component is that it's a collection of implemented classes behind an interface. Components show what elements are included in the container. Here you can see an example of a single software system. In this case, supporting elements are people, users, actors, roles, and so on, and software systems. All are directly connected to the software system in scope. Typically, you don't have responsibility or ownership of them. The intended audience can be basically everyone, technical and non-technical people inside or outside of the software development team. In this slide, the internet banking system is presented that is used by bank client. A customer can view all the information he needs and send that information to his email. Also, this banking system uses the mainframe banking system where all data is stored. Moving on, we can see that our banking system has a mobile app, single-page application, website, API application, and Oracle database. Only the API application interacts with an email system and mainframe banking system. In this modeling part, the primary elements are containers within the software system in scope. Supporting elements are people and software systems that are directly connected to the containers. The intended audience consists of only technical people inside or outside of the software development team, including software architects, developers, and support staff. Here, additional diagrams could be added, so-called nodes. However, nodes say nothing about deployment scenarios, clustering, failover, and so on. Moving on to the next slide, you can see the extended system to its components. Here, single-page application could call various API servers that are split into separate components like sign-in controller, security component, email component, and others. In this case, primary elements are components within the container in scope. Supporting elements are containers plus people and software systems directly connected to the components. The intended audience this time can only be software architects and developers. Finally, if it is needed, the code diagrams can be used. In this part, C4 uses UML class diagram. Primary elements here are code elements, classes, interfaces, objects, functions, database tables, and so on, within the components in scope. Even though C4 looks simple and easy to understand, it has some disadvantages. One is that it is created to represent static architecture and it doesn't cover other parts of the software development lifecycle. Also, it mainly describes structural perspective. However, C4 has a dynamic diagram that is based on the UML communication diagram. As you may already noticed, C4 is not a standard, and it might be changed in the future. Now let's remember what we've already learned in this lecture. C4 model is an alternative to UML that provides a defined model for software architecture visualization. The model should be easy to use and understand, whiteboard friendly. The model is based on the idea of software maps. The C4 model is oriented towards facilitating discussions about software system architecture rather than creating precise models. Thank you for your attention.